Timing resistor. When operating the 555 timer as an astable multivibrator, the value of the timing resistor should be at least 1 kilo ohms. If the idea is to build a low power consumption circuit, then it is better to have higher values for the timing resistors. But there is a disadvantage in choosing resistors with higher resistances as they lead to inaccuracies in timing. In order to minimize these inaccuracies, the value of the timing resistor shouldn't be more than 1 megaohms. Trigger pulses. Pin 2 in the 555 timer is a trigger input. When the trigger input goes below the reference voltage, i.e. 1/3 VCC, the output of the timer is high and the timing interval begins. The trigger pulse should momentarily go below the reference voltage, and the duration is important as it should not be longer than the output pulse. Trigger pulses are generally identified by a narrow negative going spike. A differentiator circuit made from a capacitor and a resistor will produce two symmetrical spikes, but a diode is used to eliminate the positive going spike. The duration of the pulse is determined by the differentiator circuit, i.e. it depends on the capacitor and resistor. Applications. Since the introduction of the IC 555 in the early 70s, it has been employed in numerous circuits and applications by researchers as well as hobbyists. Some of the important areas of applications of the 555 timer are: pulse generation, time delay generation, precision timing, sequential timing, pulse width modulation, PWM. The typical applications of a 555 timer can be differentiated by the mode of operation. Depending on the mode in which it is operated, i.e. either in astable or in monostable mode, some of the applications of IC 555 are: frequency divider, linear ramp generator, missing pulse detector, pulse position modulation, square wave generation, pulse width modulation, oscillator, tone burst generator, speed warning device, regulated DC, to, DC converter, voltage, to, frequency converter, low-cost line receiver, cable tester.